Okay, welcome back. We are going to be talking about section 10.4 in this video, where we're going to be talking about how do we graph quadratic equations. And we're going to be talking about two different types. Quadratic equations that are in standard form, and then this other form is sometimes called general form. Before we get into those forms specifically, I want to review a couple items, and that's how do we find X-intercepts and Y-intercepts. And if you will remember, to find x-intercepts, because x-intercepts are on the y-axis, that means for those values y is going to be equal to 0. So we set y equal to 0 and we solve for the x value. And then vice versa, if we want to find a y-intercept, we set x equal to 0 and we solve for y. We're going to use that as we start graphing these quadratic equations. So first of all, a quadratic equation that is in standard form has this form, the form we've been used to seeing, y equals ax squared plus bx plus c. And remember that the a, the b, and the c are just numbers. And you may or may not remember what we call the particular shape that a quadratic equation makes, but their shape we call a parabola, which is the shape that we see over here on the right, this kind of U-shaped graph. And there's a couple of important parts to this graph. The first part I want to point out is what we call the vertex, which is this lowest point down here. The vertex is either the lowest point if a parabola opens up, or if it's a parabola that opens down, the vertex is the highest point. Okay, we could also talk about where those intercepts are. We just talked about how to find them, but the intercepts are these 2 points where it would cross the x-axis. And then the y-intercept is the point where it crosses the y-axis. And then parabolas have the property that they are symmetric about the line that goes through the vertex, that kind of splits the graph in half. You'll notice that these two x-intercepts are equal distances away from this dashed line that we call the axis of symmetry, because the graph is a mirror image of itself on each side of the axis of symmetry. And so where this y-intercept is, there should be another point over here the same distance up from the y-axis. Those distances are the same, and then the same distance away from the x-axis this way as the y-intercept is. So that's because of the symmetry. So the first question we want to ask is, I think, how do we find the vertex? Well, it turns out that when we have a quadratic equation in standard form, the vertex follows this format here that you see, where we can find the x value by taking the quantity negative b over 2a. And then we get the y value by plugging whatever that happens to be back in to the function. So, and then one more thing to point out, if the leading coefficient, that's the number at the very front, the number in front of the x squared, if that coefficient is positive or greater than 0, that means the parabola is going to open up, and if it's less than 0, the parabola is going to open down. So if we move here to our first example, notice that this is really like a 1x squared, which means a equals 1, which is greater than 0, which means we expect this parabola to open up. Alright, so let's go ahead and start out here. Let's start off with finding the vertex. That's generally where we start with these problems. The vertex, remember there's an x-coordinate and a y-coordinate for any point, and the vertex, the x-coordinate is found by finding the quantity negative b divided by 2a, which in this case is going to be a negative 4 or a positive 4 all over 2 times 1, which is 4 over 2, which is 2. So that's the x-coordinate of the vertex. The y-coordinate we get by just plugging back into our function. So this is going to be, instead of x squared, it's 2 squared. This is, we're using our original function here, or equation. 2 squared minus 4 times x, or 4 times 2, minus 12, which is 4, minus 8, minus 12, or minus 16. So our vertex is at the point 2, negative 16. Probably also a good idea to find the X-Intercept. The X-Intercept remember we let y equal 0. So we're going to take our equation, y equals x squared minus 4x minus 12, and we're going to let y equal 0. Which, what do you know? We know how to solve equations like this. This is a simple quadratic equation that factors to x minus 6 and x plus 2. Now if it wasn't factorable, we could have used what to solve it? You should say the quadratic formula. And this gives me that x equals 6 and x equals negative 2. Which is really two different points. It's the point 6, 0. Why is it 6, 0? Well, x is 6 when y is 0. To find x-intercepts, we let y equals 0. So then the other point would be negative 2, 0. And then the second thing we could do is find the y-intercept. To find the y-intercept, we let x equals 0, in which case we have y equals 0 squared minus 4 times 0 minus 12, which is just negative 12. So that gives us the point 0, negative 12. And you should always notice that when we're in this standard form, the y-intercept is always going to be the c value, because the ax squared and the bx terms will go to 0, and so we'll just be left with whatever c is. And so this is enough information really to go ahead and graph our quadratic equation. So I'm going to go ahead and put some axes on here. Alright, so let's go ahead and put these points on. First we have a vertex at 2, negative 16. It's right there. That's the point 2, negative 16. We have x-intercepts at negative 2, 0, and 6, 0. We have a y-intercept at 0, negative 12. And here's where we can use a little bit of our symmetry. Remember, this is our axis of symmetry. If I put a little red dashed line in here, which means we should have a mirror image on the left side and the right side of this line. If I draw that all the way up, which means if this point, this y-intercept point, is 2 units away, we should have another we should have another point over here on the other side 2 units away, which is at x equals 4, and it has the same y value. It's 4, negative 12. And this is really enough to go ahead and graph our parabola. Okay, so there we go. Anytime you graph a parabola, you should have the vertex, you should have the intercepts, and you should have a symmetric shape about the axis of symmetry. Let's go ahead and look at one more of these. So if we start off again with the vertex, this one's a little bit uglier because it has fractions, but it's still the same idea. We find the x value of the vertex, the x coordinate, by taking negative b over 2a, which is negative a negative 5 halves, which is a positive 5 halves, over 2 times negative 1/4, which is 5 halves divided by negative 2 over 4, because we can treat this like 2 over 1. This can be simplified to 5 halves over negative 1/2. Instead of dividing 5 halves by negative 1/2, we can multiply by negative 2 over 1, which the 2's cross cancel, and we end up just getting negative 5. So x is negative 5. And we can find the y value by plugging that back into x. So we could have negative 1/4 times negative 5 squared minus 5 halves times negative 5 minus 4. Let's go ahead and do this on our calculator. We have negative 1 divided by 4 times negative 5 squared minus 5 divided by 2 times negative 5 minus 4 is 2.25, which we can put in as a fraction, is 9/4. Or you could work this out by hand too. But so we ended up getting then that our vertex is the point negative 5 9/4, which is about negative 5 2.25. Okay, so there's the vertex. So we do the Y-intercept. Remember, we let x equals 0, so that gives us, if x equals 0, that means y equals 0 minus 4, which equals negative 4. So the Y-intercept is the point 0, negative 4. The X-intercept, we let y equals 0, which gives us 0 equals negative 1/4 x squared minus 5 halves x minus 4. And since this is now an equation with fractions, let's go ahead and clear the fractions by multiplying by the least common denominator. Let's multiply by 4 and times 4 and times 4 and times 4. Here the 4's cancel. Here 2 goes into 4 twice. So 4 times 0 is 0, giving us negative x squared minus 5 times 2 times x, or minus 10x, minus 16. And this is a quadratic, but normally we want to think about quadratics with our x squared as the positive term. So let's move everything to the other side. That makes it a positive x squared, a positive 10x, and a positive 16 equals 0, which is factorable. Factors to x plus 2, x plus 8, which gives us x equals negative 2, and x equals negative 8. So we have the points negative 2, 0, negative 8, 0, which is more than enough to be able to graph this quadratic. Okay, so let's go ahead and put these points on. We have the vertex, and notice before we do that actually that since the first term is negative, this is going to open down. It's going to open down. And so let's see what happens as we lay these points out. The first point is negative 5, 2.25. It's right about there. It's negative 5, 9/4. We have the Y-intercept is at 0, -4. We have an X-intercept at -2, 0. Then another one at -8, 0. And then if we draw our axis of symmetry back on here, this Y-intercept is 5 units away, which means we're going to have another point over here 5 units away. Which would be the point -10, -4. And that gives us a nice parabola. So now we got an example of one that opens up, one that opens down. We could also graph this using our graphing calculator. Let's go and ahead and see how that works. We've done this before. Recall that you want to go to y equals button. If there's anything in there, just hit the clear button to get rid of it. And just type in the equation. Negative, remember you want to use the negative button below the 3, so -1 divided by 4 x squared minus 5 divided by 2 x minus 4. And hit the graph button. And that pretty much looks like what we have. Remember that we can go to table, so if we hit second graph, you see the table of values. There's the -2, 0 intercept. We also have 0, -4. Let's go find our vertex at -5. That's at 2.25. And you can see the points fill in. So you can use also the graphing calculator to help you do this if you would prefer. And we have one more type of equation that I want to look at, and that's when quadratic equations have this form a times x minus a squared plus k. And this is that shifting form. It's really easy to see the shifting that's going on. This tells us that our vertex, and actually our entire quadratic for that matter, has been shifted right or left, depending on what h is, and up or down, depending on what k is. This is where we said if whatever happens inside the parentheses, that's the right-left shift, and we think the opposite. And whatever happens with the k outside, that we do exactly what it says. So right here, if you'll remember, we did this before. This is like a shift right by 1. We do the opposite. And then here, this is a shift, in fact, down 4. So instead of having a quadratic that's got a vertex at 0, 0, this vertex has been shifted right 1 and down 4. We got to shift right 1 and down 4, which means the shifted parabola will look something more like this. And so we could put that on the graph. Okay, so if the vertex starts at 0, or if we start from 0, then our vertex is going to be right 1, down 4. That means the vertex is at 1, -4. The vertex is at 1, -4. Still, because this is 1 in front, that's just greater than 0, this is going to open up. We still find the y-intercept the same way. We let x equal 0, so this is y equals 0 minus 1 squared minus 4. We're just plugging in x equals 0 into our original equation. So this gives us negative 1 squared minus 4, which is 1 minus 4, which is negative 3. So we have the point 0, negative 3. Which we can put on the graph. We could also find the X-Intercept. Letting y equals 0, that's 0 equals x minus 1 squared minus 4. Which gives us, now this is one of those quadratics where we have something squared, so there's a couple different ways to do it, but the easiest way is to add 4 to both sides. Which gives us 4 equals x minus 1 squared. Remember we did this the other day. Then we can apply the square root property. Take the square root of both sides, so we get plus or minus 4. Or plus or minus the square root of 4 is equal to x minus 1, which gives us plus or minus 2 equals x minus 1. And lastly, if we add 1 to both sides, this gives us that x equals 1 plus or minus 2, which is 1 plus 2, which is 3, or 1 minus 2, which is negative 1. So we have the point 3, 0, and negative 1, 0. We have 3, 0, negative 1, 0. Then using our symmetry, we also have the point 2, negative 3. And there you go. There's a sketch of this particular parabola. Alright, thank you for your time.